Hi everyone, in this we will design a 8-bit counter that generates a 1 clock cycle pulse whenever the counter reaches its maximum value, which is 255. Let's understand the code step by step. First, we have two input signals, clock and reset. The clock signal drives the sequential logic, while reset is an active low asynchronous reset. Whenever reset goes low, the counter is immediately reset to 0 regardless of the clock. Next, we have two outputs. The first output is count, which is an 8-bit register that stores the current count value. The second output is increment. This is a 1 clock cycle pulse that becomes high only when the counter reaches 255. Now let's look at the always underscore FF block. Since it is sensitive to the positive edge of the clock and the negative edge of the reset, it describes sequential logic with an asynchronous active low reset. Inside the reset condition, we initialize both outputs. The counter is reset to 0 and the increment signal is also cleared. Now let's see what happens during normal operation. At the beginning of every clock cycle, we assign increment to 0. This is important because we want increment to behave like a pulse instead of remaining high continuously. Next, we check whether the counter has reached its maximum value. If the count equals 255, two things happen simultaneously. First, increment is asserted to 1, creating a pulse for exactly 1 clock cycle. Second, the counter wraps around and returns to 0. If the counter has not reached 255, we simply increment the count by 1. So the counter counts from 0 to 255, and when it reaches 255, it generates a 1 clock cycle pulse on increment before starting again from 0. This type of pulse generation is very common in digital design. It can be used to trigger another counter, generates periodic events, create enable signals, or indicate that a complete counting cycle has finished. I hope this example helps you understand how to generate a single cycle pulse when a counter reaches a specific value. Thanks for watching and see you in the next video.